Good afternoon, my YouTube viewers. It's Crystal here. I'm just here this afternoon because I wanted to do another code review, and this code review is going to be on a Kaggle competition. It's going to be binary classification with a software defects dataset. It's Series 3, Episode 23. So basically, what I did was I used Jax on this competition, and it said that you're supposed to predict on the probabilities. So the thing is like if you are using sklearn, sklearn has a predict proba method, but what that does is that tells you of a probability. But we're not using sklearn this time, so we can't use the predict proba. And since we can't use the predict proba, we had to use another mean. So basically, the first thing I did was use logistic regression, because that's what you use on a binary classification problem. But we had to predict on the probability. And since we had to predict on the probability, I couldn't use predict proba on Jax because there's no predict proba on Jax. And so I had to research it on the internet because I wanted to get the predict proba code and maybe translate that into Jax to use it. But there was no predict proba code for me to use. So I was looking at Stack Overflow, and they said that it has to be a regression problem. So I went back and I did the competition question in linear regression so I could get the probability that it would be 0, the probability. So that's what we've done. We've got the probability. So I did it two ways. The first way I did it was just to clip the edges. So anything less than 0 was 0, and anything greater than 1 was 1. And then I tried another way to see if I could improve it. I did min-max scaling. And so on both ways that I did it, clip edges and min-max scaling, I still got 0.77406. So what we're going to do is we're going to use clip edges, and if you want to do min-max scaling, it's a relatively easy way to do it. So here is the Jupyter notebook that I have carried out in Kaggle. And so you can see here, so the first thing that we're going to do, and what I'm going to do is I'm going to give you a copy of the Jupyter notebook so you can see it if you want to look at it, yourself, in the description box down below. So after we created our Jupyter notebook, what we want to do is we want to create the problem statement. So it says predict the probability of binary software defects. So that's your problem statement. And then what we want to do is we want to import our libraries. I import NumPy is NP as a matter of course, but if you've got Jax, then you really don't need NumPy because Jax does many of the things that NumPy does. But I will say this about Jax. Jax arrays are immutable, and because Jax arrays are immutable, although it does do the same thing that NumPy does, but I went ahead and kept NumPy in there just because I always put NumPy in there, but now we've got Jax. And Jax has been written very similar to the NumPy API, so if you know NumPy, it's easier to learn Jax. And then after NumPy, we imported Pandas as PD, and what that does is that creates data frames, and it creates data frames and processes the data. And then we're going to import OS, that's your operating system. It goes into the operating system to retrieve the files that are going to be used. We're going to be using sklearn's train test split, which is going to split the data set up into training and validation sets. We're going to import Jax, which is going to create our logistic regression or linear regression model. We're going to import jax.numpy as JNP, so that's your NumPy equivalent, but it's not really an equivalent because Jax NumPy can't do the same things that NumPy can do. As I said before, Jax arrays are immutable, so it's more difficult to work with a Jax array than it is a NumPy array. And from Jax import JIT. JIT is your just-in-time compilation, which is supposed to make the model run more quickly. And so if you got a really big data set, then it's going to come in handy to use your JIT, that's just-in-time compilation, because that'll make it run more quickly. Then we're going to import matplotlib.pyplot as PLT. That's going to visualize your data. And we're going to import Seaborn as SNS. So that's always going to visualize the data. So after we have imported our libraries, what we want to do is we want to use the OS library to download all the files that we're going to be using in the program. The 3 files that we're using in the program are going to be train, test, and sample submission. So after we've downloaded the 3 files that we're going to be using in the program, we're going to use pandas to read those files in and convert them to data frames. So the files are converted to train, test, and submission. Then what I did was I set it up so you can see all the columns. So if you've got a lot of columns and you want to see all the columns, then you have to set it up so you can see all the columns. So you can see train here. You've got 23 columns by 101,763 rows. We check info. So all the columns are going to be either float or integer except for the label. So that's good, so we don't have anything that we need to encode. Okay, so now we check our null values. We don't have any null values in the train set, so that's good. So that means we don't have anything we need to impute. We check our test. Test has everything except for the label, and it's the same as the train file other than that. We don't have any null values, so that's good. We don't have anything to impute. And now we check submission. So now on the submission file, you want the ID train, and then you want the defects. And the defects is going to be a probability. We're going to drop the ID because it's not necessary. You don't need the ID on a pandas data frame because all of the rows of data are automatically indexed. So we're going to analyze the label. What we're going to do is we're going to convert train defects to an integer type, and then when you convert train defects to an integer type, then it's automatically going to give you zeros and ones. So now what we're going to do is we're going to look at the, we're going to use Seaborn to make a histogram of the target or the labels, and you can see that you've got either a 0 or a 1, and you've also got a class imbalance. But I'm not going to be able to do anything with the class imbalance at this time because I don't know enough about Jax to actually code the class imbalance. If I was using sklearn, then I would be able to code the class imbalance using sklearn, but I can't do that. So we're just going to have to leave the class imbalance as it is until I learn more about Jax and I'm able to code in a class balance with that. Then we're going to define our dependent and independent variables. So y equals train pop defects, and then the defects is taken out of the data set, and so x is train and x test is test, and then we check the shape of that. So you can see we want to make sure that the shape is correct. Now what we're going to do is we're going to build a heat map. So a core equals x dot core, and then SNS heat map core. And so you can see we've got a lot of columns of data that have a high correlation. So what we want to do is we want to remove the columns of data that have a high correlation. And if you want to, you can try it with removing the columns of data that have a high correlation and see what you get. And then try it where you don't remove the columns of data that have a high correlation. And then you can select the best one you want. But in this particular one, I went ahead and deleted the columns of data that had a high correlation. But what I might go through is I might go through and delete that bit of code and see if the accuracy has improved. So now we're going to convert the data set to Jax arrays. So y equals JNP array y, x equals JNP array x, x test equals JNP array x test, and then you can check the shape of it too to make sure that's correct. And then so now what we're going to do after we have converted the x and y variables to Jax NumPy arrays, what we're going to do is we're going to use sklearn's train test split to split them into training and validation sets. And then we've done our shape as well, so you can see the shape of that to make sure that there's nothing wrong. So now what we're going to do is we're going to define a linear regression model using Jax. And so linear regression is one of the easier models to use. It's one of the first models that people learn when they start studying data science. So def normal equation, x, y, and then the beta is the dot product from the linear algebra inverse of the x transformed and then x, and the dot product of x transformed and then y, and then you return beta, and then predict is the dot product of x test and beta. And now what we're going to do is we're going to use JaxJit. So JaxJit is supposed to speed up the compilation time. So JIT LR equals JIT normal equation. So now we're going to check our beta equals JIT LR x train y predictions equals predict x val beta, and then you print off the y predictions. If you wanted to use JIT on the predictions, you could use JIT on the predictions as well, but I didn't do it in this instance. But if you wanted to speed up the predictions, you could do that. So the length of time that it takes to compute a JIT linear regression is 5.14 milliseconds. And now we check the root mean squared error, which is 0.38, so that's pretty good. And now what we do is we use Matplotlib to visualize the data, and so you can see the data is going to be either 0 or 1. Now we're going to predict on the test set. Predictions equals predict x test beta, and then we're going to print predictions, so you've got your predictions, And now what we're going to do is we're going to just clip it. Everything below 0 is going to be 0, and everything above 1 is going to be 1. And we're going to take that, and it's a whole bunch of arrays. So we're going to convert it to an AS array. And then there's your test predictions. And now we prepare our submission. So submission defects equals test predictions. Submission.toCSV. Submission CSV index equals false. Submission equals PD read CSV. Submission CSV and then submission. So you can tell this is our submission. And this is what we have submitted to Kaggle. And I got a 77 percentile, and the highest rank was 79 percentile. And so that's it really. That's it for this code review. So you can see how we tested on the probabilities using Jax Linear regression. And the reason why we did that is because Jax does not have a predict proba. I could not find any predict proba code where I could translate it into Jax. So I had to do a linear regression based upon something that somebody had written in in Stack Overflow. So I'm going to go ahead and conclude this video because I've covered everything that I would like to cover. I would like to thank my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, then please tap onto the bell button next to the subscribe button. And thank you so much for watching my video. I look forward to making more code reviews for you in the future.